So my system is about a biometric attendance system. So anyway, hello everyone, I'm Nampewo Margaret from Makerere University, Uganda. So my system is a biometric attendance system, and so the problem I identified, the AI problem I identified is about attendances. Since everybody knows, this is basic knowledge, everybody knows that all educational institutes take attendance, so to track who are absent, who are present. So but that thing is done manually using paper, of which papers can easily be destroyed. It takes time. So I thought of that problem, and I thought of I could do something better as an AI student to solve that problem. So that is my identified problem, that the use of papers to track the attendance of students in the education institutes. So this problem is kind of wide. It can be applied somewhere else, not apart from the educational institutes, can be applied in other parastatals that hold meetings. So it's a problem that affects almost everyone in the world. So the data set I chose is the Sokoto fingerprint data set. So this data set, why I chose it, because it held features, took into consideration of features that I thought could help me to train my module of how to identify different people based on their biometric, like on their fingerprints, and distinguish who is this, and then matches with the credentials, and then checks whether present or not. Also, on top of that, because it is taken from Africa, so I thought of it would suit better my project since I'm also in Africa. And so the features identified in my data set are the labels of gender. So how will this help me is that it will help me in case if the person's fingerprint fails to be scanned by the system. So it will train the module of how to identify or how to see the labels of the identity of the person in case the fingerprint maybe fails, because some people overwork and the ridges are maybe dismantled. So also the finger name, the hand name, all those are the features that I identified. And then the synthetically altered versions with the 3 different levels of alterations. So those are the features I identified in my data set that I chose. So the factors I considered on selecting that data set of SokoFing is that the nature of the problem I had, obviously. I couldn't go in for a data set that concerned something like management system, something of that sort. So I had to first consider which problem am I solving. So according to my problem, so this SokoFing database will work better for me. Then the levels of accuracy, since my system, the first problem, the first issue I'm solving is about impersonation, because the other traditional way of recording attendance, people can easily register for others being present, yet they are not actually present. So the levels, I consider the levels of accuracy, since this module will take the labels and the finger names of the individuals. So also the adequate research carried out by the SokoFing project, I also considered it, because I looked through other data sets, but they were not satisfying to me. Also the contention of the subsets in the data set, like the labels, like the finger names. So I considered it a best data set for my project. Then I will go into the Bayesian theorem, that can be short formed as Bayes law or Bayes rule or Bayesian reasoning. So it has many names. So this theorem just determines the probability of an event with uncertainty knowledge. So it is just, it is all about the conditional probability, what will, like, given any one event, what will be the outcome of another event. So it's a conditional, it all concerns conditional probability. Yeah. Then the naive Bayes is a probabilistic machine learning algorithm based on the Bayes theorem, used in a wide variety of classification of tasks. So just this naive Bayes just takes into use of the Bayes theorem. Then you have the Bayesian network, also known as Bayesian network, also known as the Bayes net or Bayes network, or the belief by network. So actually everything that, when you see Bayes, just get into your mind probability, but what differs is the usage of these principles. So for Bayesian network is a probabilistic graphical model that represents a set of variables and their conditional dependencies via a dialected graph. So this is just a graphical, like you say a network, it's just a graphical, it's a graphical representation. It is represented but in a form of a graph, but still it also takes into consideration of the probability principles, like the Bayesian, because Bayesian theory is the basis of all the principles, the Bayes network and all in that direction. So the difference between Bayesian theorem and the naive Bayes is that naive Bayes assumes conditional independency, which is not the case with the Bayes theorem. So I'll straight go into the difference between naive Bayes and the Bayesian networks. So Bayesian network, how do they differ? Obviously the naive Bayes, as we saw before, assumes conditional independency. So while the Bayes network will allow the user to specify which attributes are, by the way, it will allow the user to specify the attributes and then takes into consideration of the conditional independency. The other one just assumes, but this one takes into consideration. Yeah, so these are the references for my research that I've carried on, and these are the basic references. I remain Nampeo Margaret. Thanks for listening. Yeah, meet you next time.